Okay, this is 7th grade lesson 3.7b. Our objective today, students will understand their understanding of direct variation by interpreting and comparing graphs of proportional relationships. The standards covered in this lesson are 7RP2A, B, C, and D. The page numbers are 141A and B and pages 82A and B out of the practice journal. Okay, today, first of all, we're going to review through the direct variation equation that we used on our previous lesson. So here we're going to give you x's and y's, so your variables for x and y. They're telling us that they do vary directly, so they meet that straight line 0, 0 mentality. And we're going to use those values to write an equation that relates x to y. So in other words, we want to solve for k and then rewrite our equation. So our equation that we need to solve is our direct variation equation of y equals k times x. So in our first scenario, they're telling us that y is 4 and x is 2. So our first step is we're going to substitute in. So notice that I went ahead and substituted in 4 where y is in our equation. So here's our 4. And then I put our 2 where x is in our equation. So here's our 2. Our next step is to then isolate k. So to isolate k, we have to get rid of that times 2. So we divided by 2 here. And we divided by 2. The next step is to solve for k. So once we isolated and got k by itself, we found out that k was 4 divided by 2, or k equals 2. Our final step is to go through and actually substitute in or rewrite the equation. So our equation is y equals, we found out that k is 2x. And we're going to leave it in this format because remember, just like when we went through and graphed for our direct variation, we could pick multiple different numbers for x and solve for our y. So we're going to practice doing some of these now. So our first step is to go through and substitute in our numbers. Okay, so we have, using this equation, okay, so we have y equals kx. We're going to substitute in a 72 where y is. So 72 equals, we don't know k, but we know that x is 3, so we're going to put a 3 where we had x. Now I know most of you are used to seeing that as 3k, and that's okay, but if you want to rewrite it, you could rewrite it to look like this. 72 equals 3k, or you could have 3k equals 72. It doesn't matter. The key thing is that you're working to get that k by itself. So our next step is to isolate k. So divide by 3. Divide by 3. 72 divided by 3 is going to give us 24, I think. 72 divided by 3 is 24. So I just found out that k equals 24. Final step is to write our new equation. And that's just plugging in our 24 where k is. So our final statement is y equals, k was 24, and then our x. So this is our final answer. Because now we could pick different x's and solve for our y's. Okay, so let's do another one of those. Substituting in again. So we're using this equation and we're substituting in. So our y was 20 equals, we don't know our k, so we'll put our k, but we know that x is 12. Okay, so we want to get the k by itself, so we'll divide by 12. Divide by 12. So k equals 20 divided by 12 gives us 1.6 repeating. And we're just going to use the repeating symbol. So now if we go through and we substitute in, our final answer is y equals 1.6 repeating, or we could write that out as 1 2/3. And then our x right behind it. So either of these would work. The only downfall of the 1.6 repeating is that's hard to put onto a calculator. Some of your calculators will actually understand when you put in 6 multiple times that it is the repeating 6, but A lot of the lower grade calculators will not, so you might have to use the fraction form in order to substitute in for x on that one. Okay, so now I'm going to go ahead and slide 3 of them out, and I would like you guys to solve these 3. So you're going to go ahead and pause your video and work your way through substituting in and solving to get our y equals whatever our k is, and then our x, and to get them into that format where you're just substituting in for k. Pause your video now and solve through these. Okay, so those are the answers that you should have gotten for each of those. If you didn't, check with me and I can help you identify where you made your mistake. Okay, so now we're going to go ahead and work out of our practice journal. So this actually starts on page 82A out of your practice journal. Some of these are going to match what you have in your practice journal and some of them are not. So for right now, these are not ones that are on there. These are actually in your hardcover book. If you want to look out of your hardcover book, it's page 141A. Okay, so here we've got a situation. It says the distance traveled by a high-speed train is proportional to the number of hours traveled. So they're showing us a direct variation still. It says interpret each plotted point. So notice that the plotted points are the dots that they have on here, 0, 0, 1, 200, and 4, 800. Those are what we have listed here. And they want us to interpret what each of those means. So if we can interpret one of them, then we can understand the rest of them. So I never pick 0, 0 to help me interpret because it doesn't tell me a whole lot. So I'm going to pick one of the other ones. I'll go ahead and do the 4, 800. So in order to understand what that means, I'm going to follow my lines to see what my 4 in this case is hours. So our 800 is our distance in kilometers. So here we could travel for 4 hours. Would take us 800 kilometers. Or you could say I traveled 800 kilometers in 4 hours. However you would like to go ahead and understand that. So then this next one is the same concept. Our 1 is representing our hours, so 1 hour. I could travel 200 kilometers. And then my 0, 0, well, would be at 0 hours. I would travel 0 kilometers. So that's interpreting what each of those plotted points means. The next question says, what is the speed of the train in miles per hour? So I'm going to pick any of those sets of coordinates other than 0, 0, because obviously 0, 0 is going to say 0 miles per kilometer. So this should have been actually, what is the speed of the train in kilometers? It's a typo, kilometers per hour. So we're going to go ahead and figure out our kilometers per hour. So kilometers, I'll just pick this one. So my kilometers was 800. Per my hours was 4. And if I reduce that down, it becomes 200, or 800 divided by 4 is 200 kilometers per hour. Now, if they really did want us to change that into miles per hour, we could jump back into what we did back in lesson, I think it was lesson 5 or 6, where we worked with conversions. So our conversion, I'm going to set it up as a ratio and not worry about the fact that it is a rate. I want to convert 200 kilometers into hours. So our conversion, pull my book out here really quick out of the back of my book. 1 kilometer is 0.6 miles. So 1 kilometer is 0.6 miles. So now I could set that up as a proportion, cross multiply. So 0.6 times 200. And then divided by 1 is still 120. So really this is 120 miles per hour. So either of these would work. But if they did specifically ask 4 miles per hour, we would have to do that next step. So here it says, how far could the train go in 11 hours? So we're just gonna go, how many kilometers could it go in 11 hours? So you can really use any of your original rates if you wanted to, or you could use your reduced rate of 200 kilometers per 1 hour. So 200 kilometers you could go in 1 hour. How far could you go in 11 hours? And I know some of you can just go through and say, well, I know I'm going to multiply 11 times 200. So 200 times 11 is going to give me 2,200 kilometers. So that's how far we could go in 11 hours. If I wanted to figure out what that was in miles, well, I do 0.6 times that. It'd be 1,320 miles. So that's quite a ways in 11 hours. Okay, so that's working with interpreting information off of a graph, and we did work with graphs a little bit in our previous lesson. Okay, so let's try another one. Oops. Get rid of these. Sorry. I'm gonna get rid of these lines. Okay, so here's our next information. It says interpret each plotted point in the graph of the proportional relationship. So we have money here, and they want us to interpret each point. So I'm going to go ahead and do my points of 0, 0, 1, 15, and 4, 60. So we're going to go ahead and interpret what each of those means. So I'm going to start with the 460. So my 4 was hours worked, and my 60 was dollars that I made. So 4 hours equals $60. And you can rewrite that. I made $60 in 4 hours, however you want to write it out, just so that you're understanding what the 4 and the 60 mean. So then here, 1 hour equals $15. And obviously, if I work for 0 hours, I'm going to get $0. Okay, so now what is the rate? So if you ever have one where they've got the rate where the you've got 1 in your X, well, that is your rate. You're going to get $15 per hour, or you can take any of these and set them up as the rate in dollars per hour. So I could take 60 over 4 for my dollars per hour, which is still going to give me that $15 per hour. If you were to work for 10 hours, what would your earnings be? So notice that on the graph, I don't have 10 hours. So I'm going to have to either use a proportion or use my unit rate. So if I'm going to get $15 for 1 hour, or I could use the 60 over 4, how much would I get for 10 hours? So this is very visual. I know some of you don't need that proportion, but some of you do. So then 10 times 15 would give me $150. Okay. Okay, so let's go ahead and look at one more here. Oh, love it when things fall apart there. So let's look at this one. Okay, oh, let's keep bouncing out. Okay, so here I've got a hot air balloon. So my points are 0, 0, and 1, 5, and 6, 30. And let's see, I like to always use the one that's furthest out just because there's most space. So my 6 is seconds, and my 30 is feet. So here at 6 seconds, I'm 30 feet high. Okay, so then that means here at 1 second, I am 5 feet high. Oops, and then I spelled height, not even spelling it right. And then here, this would be 0 seconds, would be 0 feet high. So I'm on the ground. Okay, so now what is the rate? So my rate, I'm just gonna pull from right here, my rate is 5 feet per second. And I know that's reversing it. Remember, rate is always your slope or your rise over your run. So that's where you're putting your y over your x. What would the height of the hot air balloon be after 9 seconds? So if I use my 5 feet per 1 second, and we want to know after 9 seconds, matching labels, cross multiply, 9 times 5 would give me 45 feet high. Okay, so that's what you're going to be working with on your practice journal, page 82A. So that's what you'll have for homework for this part of the lesson. But I'm going to go over a couple where you're working with some like sales tax and things like that, because that's the 82, or what was it, 82B is working with some additional where they're actually giving you 2 lines instead of 1. So here it says the sales tax in Maine and New York are proportional to the price of a purchase, as shown in the graph. So in other words, you're going to pay so much per dollar of sales tax. Just like in Iowa, it's 8 cents, I think, in most places. Some places are different because maybe their county has a higher percentage rate. It says express the sales tax rate for each state as a percent. So we're going to do our cents per dollar. So for Maine, since that was in red, I'm going to pull the number that they gave me on Maine, and that was this one right here. And that was, the 1 was our price, our dollars, and the 5 was our cents. So cents, 5 cents per $1. And I'm going to actually put this in as 0.05 cents per dollar. And then for our blue line, New York, and we'll finish this out in just a minute, but I'm pulling my data right now. I have my 5 is my dollars, and the 20 then was our cents. Okay, so we're going to go ahead, and when we work this, we have to figure out the percentage. So to change a fraction, which we have 0.05 over a dollar, into a percent, we have to change it to its decimal form. So 0.05 divided by $1 gives me 0.05. Well, that's pretty easy. Now, as a percent, we would go 2 places to the right. So this is 5%. So for Maine, it was 5%, and I should have done that in red. And for New York, okay, so we're going to punch in 0.2 or 0.20 divided by $5 gives me 0.04, which is the same as 4%. So New York was a 4% tax. Letter B says, what is the sales tax on a $12 purchase in New York? So it's your choice if you want to use that percentage, if you're comfortable with percentage. Otherwise, we can use the information that they gave us. So I'm going to go ahead and just pull this right here. And remember, it was tax, your cents tax, over our dollars spent. Okay, so let's see. Our original rate was 20 cents for a $5 purchase. And that's just, I just pulled that from right here. And then the new bit of information was a $12 purchase, so that's going to go on the bottom. And now we can cross multiply, divide. Or we could figure out 4% of $12. That's up to you if you're more comfortable with doing that. So 12 times 0.20 divided by $5 gives me 48 cents. So I'm going to pay 48 cents tax on a $12 purchase in New York. So you can either use the percentage there, or you can set it up as another proportion and just make sure that you're matching labels. That's pretty much it for this lesson. So you'll do pages 82A and B, and on the back side, B is working where you have 2 lines and working with some percentages. So you're going to have to do kind of a double play. And here we worked with Maine and New York. And on page 82B, you'll be working with like waiter A and waiter B, and salesman A and salesman B. And once again, you will be working with percentages there. So good luck. If you need some help getting started on 82B, be sure to ask. And good luck with this part.